Okay, welcome everyone to this edition of the Opentrons demo webinar. Great to have you here. We'll just get started in 1 sec as soon as we've let everyone have a chance to just join us and log in. Okay, so good morning and afternoon to everyone, and welcome to the live demo webinar focusing on how to automate your workflows on the Opentrons Flex. My name is Fran Slater. This was supposed to be a Nick and Nick show, but unfortunately Nick couldn't make it, so you have me instead. But I am joined with one of my colleagues, Nick Ritzo, our product specialist. So today we'll show you the Opentrons Flex, and we'll talk through some key features, such as the pipettes, the modules. We'll talk about a new hardware accessory that we have up here, and some new software functionality. And then Nick will take you through a demo automating a workflow on the Flex using a protocol downloaded from the Opentrons protocol library. This is a very easy process to get existing protocols, some of which have been verified by our scientists or reagent partners, to run on your robot. And we'll show you how to alter key parameters such as sample number from run to run. And then finally, we'll answer any questions you may have at the end of the demo. So I'm just going to pause here for a minute just to make sure everyone is signed up and comfortable. And I'll use this time to just plug our demo room, which is where this webinar is taking place. So this demo room is in our headquarters, which is in Long Island City, New York. And if you or anyone from your team are in the area, either visiting or if you live here, then please feel free to work with your main point of contact at Opentrons to schedule a visit. We'd love to see you here. You can check out our office and meet the team, and of course, see the Opentrons Flex in person. Okay, so I think we might be good to go now. So just a quick reminder before we start that this webinar is being recorded and it will be made available on the Opentrons website after we've finished. And we'll also send a copy of the recording via email after the webinar. So to help with everyone's experience, everyone's on mute. To ask a question, you can use the Q&A box at the bottom of your screen, and we'll answer your questions at the end of the talk. Okay, so before we get started talking about the robot, I wanted to say a few things about Opentrons ethos and why we exist. So it's our mission to support scientists doing groundbreaking, valuable research with powerful, accessible lab automation. And our aim is to really free you to do more than pipette and be able to focus on science. We've helped thousands of labs across the world automate their workflows. And with the Opentrons Flex, which is our newest generation robot, we're excited to show you how it can help you and your lab increase your throughput and automate your workflows. Okay, so jumping in to talk about the Flex itself, I'm going to show you a few key features on the Flex, and then Nick is going to run through a short demo about finding and configuring a pre-existing protocol from the library, and then running it, and then we'll take questions, as I mentioned. But you can type in your questions at any point, so from now on. So our software engineer, Nick Diehl, is monitoring the Q&A box while we talk, so feel free to ask questions at any point. Okay, so this is the Flex. And as you can see, the thing that just moved to the front is the gantry. The gantry holds 1 or 2 pipettes. Here we have 2 pipettes, a single and an 8-channel, and then also a gripper on the right-hand side next to the pipettes. So the pipettes, as I mentioned, we have a single and an 8-channel here. Both the single and the 8-channel come in 2 volume configurations. So the P50, which covers 1 to 50 microliters, and the P1000, which covers 5 to 1,000 microliters. The 96-channel pipette, which you don't see actually on this robot, comes in 1 size, and that's 5 to 1,000. With the 96 channel, you can obviously pipette 96 samples all at once, but you can also do something called partial tip pickup, which allows the 96 channel to pick up either 1 tip, 1 row of tips, 1 column of tips, and in the future, several rows of columns. So in that regard, you can really use the 96 to provide a whole bunch of different ways to kind of pipette things around the deck. One thing to note is you can hold any combination of single and 8s on the gantry. So you can have 2 singles, 2 multis, or as we have here, a single and a multi next to each other. Or you can have the 96 channel on its own just because it takes up sort of the whole space here. And as I mentioned, we've got the gripper on the right-hand side or left-hand side, depending on how you're looking at it, of the pipettes, which can move tip racks and plates across the deck and into the trash bin at the back. We also have a trash chute available, which you can't see on this robot because it sort of takes up a lot of space. It attaches to the front here and allows you to put your waste into an external bin, which sort of really supports higher throughput workflows and kind of extending the walkaway time that you can achieve with a benchtop robot. Okay, so moving down to the deck. So the deck has 12 standard slots here, where you can put tips, labware, modules, and so on. There are also 4 extension deck slots. You can actually see 2 of them here to the right of the main deck. And these can be used to hold extra tips and labware. The gripper can access the 12 standard deck slots. It can also access the extension slots on the right, allowing you to bring in additional labware and tips onto the main deck so that the pipettes can access them. It's kind of an important thing to note that the modules here are all flexible. You can move them around. We'll just talk through what's on the deck right now. First of all, we have a magnetic block here in the middle. It's a standard 96 well magnet plate. Over here, we have a heater shaker, which can shake from 200 to 3000 RPM and heat to 95 degrees C. Behind it, a temperature module, which can go from 4 to 95 degrees C. And at the back, you can kind of just see the lid here is the Opentrons thermocycler, which can automatically open and close using the software. And so it's a really kind of unique option for automating kind of PCR and other workflows. And finally, I mentioned at the beginning, we just recently launched this HEPA UV accessory that sits neatly on top of the robot and allows you to sterilize the deck surface and also filter contaminants from the working area. And as I mentioned before, all of this is completely modular. So you're not tied to this robot doing one thing forever. You can easily swap out pipettes, modules, and so on to change the application that you're using it for or to increase your throughput. One final thing that I just wanted to mention is this on-deck touchscreen, which allows you to easily store and pull up and then run protocols. It also guides you through deck setup, and Nick will talk you through that in a minute, and an automated calibration. And kind of most importantly, it's really here to provide you with a lot of prompts and guidance. So it really makes the steps that you go through before the robot starts to run really straightforward and easy to follow. And that should be for anyone in the lab to carry out experiments on this robot, whether they're really experienced with automation and Opentrons products or not experienced with automation at all. And finally, I just wanted to talk about our service offerings. So we offer a white glove approach to service for our users. So that includes on-site installation of the robot, training for your team, or from one of our specialized field application scientists. They also provide you with kind of on-site support, quick turnaround time, ongoing preventative maintenance, and IQ/OQ. So we have both field application scientists to really act as your technical and application automation consultants, as well as field application engineers who are more focused on the ongoing support and PMs for your robot. And if you want to know more about services, please talk to your local territory manager, and they will be able to discuss kind of what kind of service and support offerings are best for you and your lab. Okay, and with that, I'm going to pass the mic over to Nick, who will run through finding and configuring a protocol in the library and then running it on the Flex.
Thank you so much, Fran. Hi, everybody. Hope everyone's day is going well. I'm just resetting the robot here as we get prepped for the demo. First, I want to give an overview of the different ways that you can create protocols for your workflows on the Flex. As Fran mentioned, an FAS from Opentrons team can actually provide on-site application development and optimization. It's great to have them working there with you. We do also offer remote protocol development and optimization. And you do also have the option to write protocols yourself, either through our Python API or through one of our UI-driven tools, such as Protocol Designer. And finally, the option that I'm going to talk about today is how to download a pre-existing protocol from our open access protocol library, which is a repository of pre-designed protocols, which cover a wide range of applications, from DNA extractions to PCR setups. And I'm going to walk you through the process of finding and then downloading and then finally uploading a protocol, which is going to fit your needs and hopefully fit the workflows. First, we'll need to navigate to the protocol library. You can do this through our website, and there you can browse the extensive collection of protocols. Opentrons really is trying to simplify the complexity of these procedures and ensure accuracy and reproducibility for your lab space and the other lab spaces that we are reaching. Additionally, we have a number of verified protocols that our in-house science team or the relevant kit manufacturers have tested, which are then going to be given to you. To find the protocol that fits our needs, we can search, or we have a pretty extensive filtering tool set, which is going to allow us to browse based on a category such as application. Today, I'm going to be showing you a trypsin-based digestion, and there's going to be kind of several ones that are going to pop up. And I'll show you also how to kind of filter through those to kind of find the one that's best going to fit your needs and the kind of relevant robot information that you'll have up. So the first thing I'm going to do here is I'm actually going to share my screen, and we're going to navigate over to the Opentrons website. So I hope everyone can see my screen now. So here you'll have the basic web page. You have several features that we have, as I talked about, the protocol designer, which is one of our other kind of UI-based protocol creation or authorship tools. We have extensive Python API documentation, as well as a labware library and our GitHub repo. Here I'm going to click on the protocol library tab. We do have some pinned tabs or some pinned protocols, which are kind of, the most relevant currently, or, kind of maybe they're newer that we just debuted. As I said before, I'm now going to search for trypsin. And there's going to be about 5 results that pop up here. I know that I'm going to be looking for one that's on the Flex. So just scrolling down to these robot models here, I'm going to find one that's for the Flex. And then I'm also going to find one that has custom parameters designed for every run here. So instead of just having these protocol parameters pop up at the download, we now have feature sets written into the Python command set that allow you to modify parameters either from the app or on the touch screen every run. So it really creates a very kind of flexible and robust protocol from one space. So clicking into this, I can start to see, kind of more of the meat of what these protocols are actually going to be able to accomplish. Over on the left-hand side here, I have kind of, a human readable format for everything that is going to occur in this protocol. As you go through this, it'll kind of discuss, what reagents are there, what are they actually doing, what is the end result of this going to be. Over on the right-hand side, I have what the kind of relevant deck setup is. As I scroll down, I can see kind of a more detailed view of this deck setup. You can start to see a little bit more of what modules are required, and these are also called out over here on the left-hand side. All of the relevant labwares will also be called out. Clicking into any of these, you can pop up what exact labware this is, and you can also shop for them. The same kind of behavior also holds true for the modules and also the pipettes that we will be using here. A quick note is that specifically with these editable protocols, you can download them and change some features such as the pipettes that are necessary. Here we already have the robot configured for the correct setup, so it's going to be kind of a one-to-one kind of comparison here. But you do always have the ability to modify those. We do also have another product offering in terms of a protocol amendment, in which our FAS team will also come either on-site or remotely and modify a protocol that is already in existence. But hopefully the protocol library is going to get you very close to being able to get up and running immediately. As I scroll further down, we also have some further kind of examples of what this protocol is actually going to perform. These are definitely abstractions. The protocol itself, as I mentioned, is written out in Python steps. So all of these, protocol steps here are going to be written out kind of in much more robust kind of coded language, but this is the general idea. And we will also have these tables, which make more sense as I scroll all the way to the bottom to discuss what the runtime parameters of interest are here. A very popular runtime parameter is going to be number of samples. So here the default number of samples is going to be 96. As you can see, we can drop this all the way down to 1. We also have what labware is going to hold our samples, so we can select what tube type. We have how long of a digestion period are we going to have for the trypsin, and also in which position on the left or the right mount is our one-channel pipette. So if I scroll back up, these tables make a little bit more sense now in terms of what amount of reagent do we need to have in each of the columns for the relevant number of samples here. As you can see, the sample count here is broken out by the individual columns. So it goes from 8, 16, 24. And the same is true up here for the other labwares that are necessary. Scrolling back down, we do also have some reference publications, which you can click into to kind of gain a deeper understanding of the science that is being supported here. And if I scroll all the way back up, I can go ahead and actually download this protocol. So once that has been downloaded, I can navigate over to my Opentrons app, which I already have open here. If you have protocols downloaded previously, this screen will show those. Instead, though, I can just click that I'm going to upload a protocol here. If I scroll down past all of my blanks and open this protocol, it's going to perform an apt analysis of this. So this is going to now kind of be in a verified state. I can always reanalyze this or start the setup here. I also have the option to send this to an Opentrons Flex. As you can see, we do have several that are available to us, which makes sense as we are at Opentrons HQ here. If I scroll back over, I also have the ability to look at the current settings that are relevant to this instrument that is sitting behind me. This is just a kind of a screen share of what is happening on the touch screen here. And so the touch screen has a ton of relevant information that will help you out as you get things moving. Here you can see what the robot name is. If I clicked into network settings, I could see things such as IP address and other features that are going to be helpful. But if I know that this is going to be on freezer, I can click that I'm going to be performing all of this on the freezer and send this over. So now if I look at all of the protocols that are on this instrument, I can see that I have trypsin digestion. And this is also going to pull up information that is very similar to what was shown on the library or on the protocol library downloads page. I don't know if you can see it over in the corner there, but this is also populating directly onto the touchscreen on the robot next to me. So you can see the summary. You can either pin or unpin a protocol, which is basically going to bring it to the front as you run it. You can see what the parameters are and what their default values are. You can see the relevant hardware and what is currently mounted. If there are any discrepancies between the hardware that is actually mounted on the instrument and the one that is necessary to run the protocol, those are going to show up here. And you will have to resolve those before you can actually start the setup. It will show you what the relevant labware is, as well as the relevant quantities of them. All of the liquids which have been created in the protocol are highlighted here as well. These are going to be based off of some of the relevant runtime parameters. And lastly, you can see what the deck is and how it is set up. This is also based off of some of the relevant parameters. I have changed the defaults here to actually utilize a much smaller subset of samples. In the previous one, it was actually kind of using all of these locations. But now I can go ahead and I can say start the setup here. The first thing that it's going to do is ask me to fill in any of the runtime parameters that are necessary. So I can go ahead and specify that instead of 1, I'm just going to run, or 8, I'm just going to run 1 sample here for the sake of time. I can specify the tubes and the digestion period. Again, I'm going to make that kind of as short as possible just for demo's sake. Once I confirm these values, it's just going to check to make sure that they haven't broken anything. And then all of these other ones, if there were anything that is lacking or any kind of hardware differences, these would actually pop up as yellow and you would have to adjust them. Instead, now I have the ability to run this protocol. I can actually stop the share here so that it will pop back up into the robot view. And I can go ahead and click run on this. The first thing that this is going to ask me to do is it's actually going to open the thermocycler lid first, and then it will ask me to put on a plate, which is going to house our reagents, as these will typically be kept on ice before you want to put them onto the deck. And so this is another great example of how helpful the touchscreen is, so that you can be keeping your reagents somewhere else, refrigerated. You could even not have them prepared until this screen pops up and the protocol will pause for you. And then without interacting with your computer whatsoever, you can confirm and resume. As you can also maybe tell, there are just kind of short descriptions of each step that are going to populate in. This is another really helpful feature of protocols that have been downloaded from the protocol library, is that these are kind of written out in the Python script as kind of commented out lines. And so it's really kind of very nice to see what these relevant steps look like in kind of a robustly designed protocol. As you saw in the tables, this protocol is designed for kind of column-based work. For demo purposes, I just shorten it to only do one sample, but we are still going to use the 8-channel pipette here to take all of these reagents in order to do this kind of quickly. So these will be deposited into the plate that's on the thermocycler. Because the plate is already on the thermocycler for this as well, which is like kind of a really nifty trick to save time and also save deck space, we will not need to have any kind of gripper interaction. If the plate were to need other steps, such as magnetic heat cleanup, the plate would obviously have to start in a different location, and then the on-deck gripper can really shine. Here we will add 2 relevant reagents, ABC and DPT, to the sample count here. And then once these have been completed, again, for the sake of demo, we are going to skip the 2 subsequent incubation steps, where further reagents would be added, and then fixing would also be added, and we can select how long of an incubation period we want. So instead, once this lid reaches the set temperature that is relevant for it, the thermocycler will close automatically, and we can pause the protocol afterwards. So as soon as this is closed and locked, we can go ahead and pause and then move forward with questions.
Okay, I'm going to hop back in. And then thank you very much, Nick. Thank you very much, Freezer Robots. So I was going to introduce Nick Diehl, who is on the call as well, and who has been monitoring your questions that I've seen have been popping in as we've talked. And so Nick is just going to go through those questions in order.
Yes, thank you, Fran and Nick. Sorry that I'm not there, but I'm happy to be helping out on the other side of the camera. So got some great questions that we should have time to get through all of them. Maybe let's start from the top. So this one's interesting. Is the Flex capable of integrating an in-gel protein digestion protocol, i.e. can liquid solvents be added, mixed, and subtracted without accidentally picking up and or breaking roughly 1 cubic millimeter gel pieces?
That is a great question. I do not think we have tried to do that. I think it, I mean, we could have a go at it, but we haven't tried to do it, I don't think.
No, but I mean, if the, kind of necessary steps are that, we pipette, pretty accurately or very accurately to set locations like within those wells, I think that we would probably need to have, some troubleshooting and some optimizations around what those kind of aspiration and dispense heights look like. But we should totally have the capacity to do that on the Flex. As Fran was saying, I don't believe that we've done that exact use case. But
Yeah.
definitely something that we would be willing to try out. That would probably be something that would fall kind of into the category of having an FAS come to do some on-site protocol development and optimization. Utilizing the strengths of that team and a lot of their understandings to get us kind of a lot closer to that as a viable kind of procedure. Probably not something that we'd find right now on the protocol library.
Yeah. Yeah, I mean, I think as Nick said, like the pipetting accuracy and the sort of fine control of the pipetting is something we feel very confident in. I think it's just the challenge of like not picking up those gel pieces, which we'd have to troubleshoot.
Yeah, that definitely sounds right. I think it will depend on the bore size of the pipette relative to those gel pieces. So this user is anonymous. If you'd like to shoot us another message, we could talk offline after the call about addressing this. So I'll mark that as done. All right, Guillaume asks, does the pipette offer repeat pipetting? I'm happy to jump in there. So we do offer repeat pipetting. We can kind of go either way. So our distribute functionality allows us to pick up a large quantity of liquid and transfer to many wells, or go in the other direction. We can consolidate from a large number of wells to a single well, or many to many in different combinations. So the answer there is going to be yes. Moving on, Guillaume asks, what is the error rate of these pipettes at low volumes?
So those values are published on our website as well. Do you have them off the top of your head?
I don't have them off the top of my head, but if you go to the pipettes page on our website and scroll down under tech specs, you can see the error ratings at different volumes.
All right.
I think it's right around 5% CV.
Great. Jeff asks, is the Flex able to pipette stronger acids, e.g. formic, and organic solvents like isopropanol or chloroform? Would the solvent reservoirs for this need to be unique?
So we do have some limitations in terms of the sort of solvents that we can pipette. There is if this person has put in their contact details, we do have a list available online that really covers the solvents that we can't touch. So I know that some of those listed are not okay, but there is a full list available on the website. And if they've put their contact details in, then we can send it to them afterwards.
Yeah, and kind of just to add to that, off of that kind of chemical compatibility list, there are kind of various components on the Flex as well as in the labwares, right, which are all going to be relevant and kind of like all have to have a check mark in order to utilize them. So yes, it is definitely a good idea to take a look at the relevant labware and reservoirs that you want to be using and what their kind of chemical makeup is, as well as what the chemical makeup of the tips are, and then also what the kind of relevant makeup of the pipettes is. Hopefully with filtered tips, none of that will ever come in contact. But the other kind of relevant piece of that is also to ensure things such as like vapor pressure and all of those things which also in these kind of organic and inorganic solvent world can cause issues down the line. Great.
Thanks, guys. Do you just want to flag also, we have plenty of questions rolling in, so maybe just keep that in mind as we move through. Okay, Flavio, has this robot been deployed to applications beyond pharma or medical, i.e. chemicals? Thinking of pipetting viscous or even weighted solid materials.
Yeah, I mean, we have a real kind of long tail of applications, I would say. So while the sort of the person asked the question is right, and that our sort of dominant fields are really molecular biology, genomics, proteomics, that kind of thing, we do have a lot of inorganic and organic chemistry, materials handling customers. I think it would just go back to, again, the particular nature of the pipetting. And what would needed to be pipetted. So we definitely have a lot of chemists using the robot, but we'd really need to kind of get into detail in terms of what you wanted to pipette and how. And we could definitely do that in a call with a rep and an FAS to really go through your needs.
All right, great. Enrique says, can I fit the thermocycler module, which I believe occupies 2 slots in the extension slot area, only accessible to the gripper. I'm happy to take that one. Currently on Rike, we only offer the thermocycler module to be configured in the back left 2 slots of the robot, which it's in right now. And there's a convenient kind of extension slot beyond slot A1 that allows us to place it there such that it doesn't obtrude any other slots on the deck. So the answer to that is going to be currently just in the back left of the deck. All right, William, is there a mechanism to bring plates onto the extension slots from an external source, arm or sliding nest?
Well, this is a great question and very timely. Currently, the only options are through integrating a robotic arm, like a third-party robotic arm. We do have integration tools for that. But I would say watch this space for some announcements in the near future as to a more embedded solution, let's say.
All right, it's a good tease, Fran. Great. Ihab, does it require FSC to install the 1996 channel pipette head? What about the single and multi-channel?
Oh, that is a great question. I love this question. So maybe if we move the gantry to the front, so you can install and swap out and change the pipettes and the gripper yourself. So each pipette just has 2 small screws that you would need to remove, and we provide the tools to do that. And then the pipettes kind of slot easily off, and then exactly the same putting the new one on. It's just 2 small screws to screw them in. The same with the gripper. I will just say that just as a note, like that it's very easy with the single and 8 channel pipettes. The 96 is also quite straightforward. It's just a much heavier pipette. We actually have it here. Lift it in. So it's still the same. You can still swap it in and out yourself, but it's just chunky, and you definitely need 2 people to do it.
Great. Speaking from experience, I have installed the 96 by myself. I am not particularly strong, so it's definitely doable. Great. Flavio, with another question, are the digestion modules also an Opentrons product? Interested in an acid digester?
Ooh, interesting. So we don't have any modules specifically for digestion. So the trypsin digestion that we're doing here is just really just using the thermocycler for the incubation steps, and then adding the trypsin, the DTT, IAA, and ABC reagents at the appropriate points, and then using the thermocycler to do the digestion. So we don't have a specific module for acid digestion.
Great. Moving on with plenty of questions still. For the 96 head, can I pick up a partial number of tips? If so, what configurations? I'm happy to take that one. So currently we can pick up either all 96 or a single column of tips. In our next major software release coming in the next month and a half or so, we'll be able to pick up a much larger number of configurations, including single tips, single rows, and single columns. So look forward to that in the near future for more configurations. William with a nice note, not a question, but it's seriously impressive how far Opentrons has come in a few years. Open protocols, version controlled assets, Python integration, bravo. Thank you very much, William.
Thanks, William.
Away. Guillaume, is it easy to adapt protocols to different plastics?
Ooh, yeah. So yeah, this is a great question. So we have a labware library, which has all of the dimensions and sort of specifications of a piece of labware. And that's a library in that it has a lot of existing labware sort of spec'd out in it. But you can also create custom labware where you can create essentially any configuration of labware you like. So it just involves kind of entering those specific specifications that determine, the height of the plastic, the width of the plastic, where the wells are, and so on. So yeah, there's a lot of optionality for different labware.
And I didn't show it, but an example of that would be taking a protocol from the protocol library, and if you open it up in your own kind of code editor like Visual Studio or whatever you wanted to use, you can definitely see exactly where we set up the scripts and how we kind of configure them to call out specific labwares, and you can actually go to the labware library and pull the direct name. So you don't actually even need to look at the measurements for them. You can just call them out kind of by name in that. And then through our UI tools like Protocol Designer, it's just drop-down menus of all of our kind of supported labwares. And so that is actually like an even easier process if you wanted to author it through that mechanism.
Perfect. All right, a quick one. Is the thermocycler able to be removed and reinstalled, or is it a permanent feature of the deck? Happy to take that one. It's very easily removed and reinstalled. There's a USB cable and a power plug similar to our other modules, and 2 screws hold it in place, and it's caddy. So in a matter of a couple of minutes, you can absolutely replace that with a different module caddy or a standard deck slot. All right, thanks, Jeff. Josiah, is there any way to control the speed of the pipette movements in the protocol?
Nick, do you want to take that?
Yeah, so in terms of how to control varying flow rates and what the actual aspiration and dispense speeds look like, absolutely, those are functions that can exist in any of our transfer steps, as well as a lot of the other kind of basic pipetting functions of that showed off, like touch tip, as well as blowouts and air gaps, and kind of all of those kind of advanced pipetting settings that can be utilized to optimize your pipetting steps. Absolutely.
Yeah, great. Chris, can the display show the current line of code that is running while it's running? Happy to take that one as well. It does in fact do that while the protocol is running. So it's a little bit difficult to see at the resolution we're at on the screen, but the current line will be highlighted on the on-device display or on the desktop app. If your question is regarding what line of code, meaning corresponding to the Python code, that's not something that we currently support. We do show the list of commands, and we highlight the command that is currently being run. So hopefully that answers your question. Anonymous, okay, can you specify the pipette tip depth in solution for aspiration or dispense?
So if I understand this rightly, it's sort of saying, is there a standardized sort of height? Do we think that's the question?
Yeah, I think what they're getting at, and forgive me for stealing the mic here. I think they're asking, can you specify where in the well to aspirate or dispense?
Oh, I see. Yeah. So yeah, again, that's extremely configurable within, you can specify the height and also the position, the sort of the X and the Y position in the well as well. So you can pipette out of the center of the well or to the left or the right of the well and at whatever height you need.
Great. All right, Flavio asks again, can the gripper open or close plastic bottles or crimp files?
So currently, no. It is designed kind of singularly for SBS format kind of labwares. And we don't have a kind of a configuration that would do kind of those specific motions that you're kind of asking for in terms of opening up tubes or vials or things along those lines. It's really designed to move labwares.
Great. Christopher asked a very timely question. Can a custom pick list be called at runtime by the program such that different volumes can be aspirated from different wells of a plate?
Nick, do you want to take that one too? It's right online with your project.
Happy to speak to that. So we've been working hard on expanding our runtime parameters repertoire to include uploading CSV files at runtime. So come our next major software release, this will be supported at runtime. Thank you for the question. Christian, can the 8-channel do various volumes simultaneously?
So currently, no. They are kind of all actuated off of the same plunger mechanism. So anything that happens in one of the channels of the 8-span pipette will occur in all of them. So that includes aspiration, dispense, as well as the heights relevant.
All right, great. Sarah asks, is it possible to run the protocols not through the app, but directly through the internal sheet? We would like to integrate with other equipment in reactive experiments. Therefore, we need to create an architecture able to control both the Flex and other equipments, as we already do with our OT2.
Yeah, so we do have a pretty expansive HTTP API that we utilize for most of our integration partners. And that has the ability to kind of call functions singularly. And so that is typically the route that we kind of suggest customers go down in terms of how to run in an integrated manner in the best kind of possible function. The most simple one there would be to essentially call a protocol through that, and we do have that function available. Definitely, a good question if you wanted to kind of ping us again and kind of connect internally with some of our solutions architects around what we kind of usually do in terms of integrations. That should all be documented as well.
But also, I think I caught at the end of the question that they're currently doing, they're currently running sort of separate pieces of equipment with an OT2. So if you can do it with an OT2, you can do it with a Flex.
Yep.
So and it would be very similar because the code base is the same. That it'd be a very seamless transition to integrate the Flex if you already have the OT2 running.
Yep, great point, Fran. Thank you, guys. Okay, Jan, do you have any protocols for checking the pipette volumes if they live up to specifications?
So we do actually have an upcoming IQ/OQ project in which an integrated plate reader is going to be utilized for doing functions like that. Currently, all of the pipettes come validated from manufacturing, and there are customers that you can set up kind of a gravimetric test as well. But we will be debuting kind of an internal IQ/OQ mechanism through plate reader.
Great. Enrique asks, can you comment on liquid sensing strategy? E.g., if pressure or optical sensors can detect when liquids get in touch with the tip, so to precisely estimate the volume of the well.
Again, very relevant. So we actually do have pressure sensors that are in the current Flex pipettes. It is located in the single channel, in the front and back locations, I guess, of the 8 channel, and then in A1 and H12 of the 96. And so these are entirely pressure based. And actually in our next release in a couple of months as well, we will be debuting functionality for the presence or absence of liquid in the wells. And we'll kind of continue to expand on that work in the future, but all Flex pipettes have the hardware in place to do that currently.
Right, great. Okay, maybe this is a pretty basic question. Do you guys have the capability to accurately dispense highly viscous liquids, i.e. glycerol?
Yes, we do. So we have application notes and sort of recommendations for dispensing both highly viscous and highly volatile liquids. If you go on our website, and we have a resource hub, knowledge hub there, and if you search for viscous or volatile, you should find those application notes.
Great. Is there a way to remove a supernatant from a pellet with minimal loss for a plate-based assay?
So I would probably specify here that yes, to go back to kind of one of the earlier questions, we do have kind of encoders on all of our pipettes that give us pretty exact measurements on the Z heights, and so off of that, really doing some optimization work to kind of configure the pipette to kind of consistently go to the right height to aspirate off of that pellet is kind of the best mechanism for doing that. Whether you want to do it with like a single 8 or 96 is also kind of a variable question there of how precise you want to be, since those are the 8 and 96 are not going to move to variable Z heights kind of individually. But we should be able to kind of do that fairly effectively as long as it's optimized for that.
Yeah. And I think there's also other things you can tweak, right? You can choose the right labware. Depending on where your pellet is, you can position your pipette on the X and Y axis so that you're pipetting to the side of the pellet, so you're not disrupting it. There are lots of like little tricks that can get as much of the supernatant out as possible.
Great. Okay, Josiah, regarding solvents and chemical compatibility with the pipette materials, are there any plans to develop a new line of pipettes that are more friendly to a wider range of solvents?
It's not, I mean, we do get asked this quite a lot, actually. It's not on our current roadmap to do that. But keep asking and keep asking for specific things, and then, you know, we can always look at what we might be able to add.
Great. I'm gonna pronounce this poorly. I apologize. Kisenija. When we're using the same protocol and materials, how often should we recheck calibration or position?
That's a great question, actually. So I think it's a little bit, I would say it's very user dependent. So some people like to do their, positional calibration like after every run or two, and others do it sort of once a month or less. So I would say it really depends on the parameters that you're working within and like how accurate your pipetting needs to be. I will say the calibration is now on the Flex a very easy process, and it's a very automated process. So it is really, for each piece of hardware, it is really a two-minute process. So if you do want to do it very regularly, it is possible. But I think it really depends on your needs.
Great. Okay. Where do you download the Opentrons software, and what is your suggestion for first-time users on how to start a protocol?
Yeah, so actually in that same protocol library, if I continue to scroll down, there's actually a link out to the app, and you can download it directly from our website. A great area to start to understand what a protocol looks like. There are more simple protocols that are located in the protocol library compared to the strips and digestion, such as PCR setups, things like that, as well as our UI tool, Protocol Designer, to kind of just give you a very easy UI interface to kind of interact with to build out protocols. And then another really good option is the on-site or remote protocol development by FAS, so that you have kind of like these really robust, kind of well thought out starting points if you wanted to continue to tweak on, or probably hopefully just a protocol to run with very immediately that is kind of exactly what your lab space needs.
Great. Okay. We have 10 minutes left and about 11 questions, so hopefully we can get to them all. Thanks, guys, for getting through all of these. Is there a limitation to what types of plates the gripper can move? Can it move unskirted plates? From Jacqueline.
That's a great question. So as Nick mentioned, it is sort of limited to SBS format labware. We do recommend skirted or semi-skirted plates, particularly if you're going to be using the gripper in conjunction with the thermocycler, just because you have the gripper pressure that's sort of changing things, and also the heat of the thermocycler. So we do recommend skirted or semi-skirted. Sorry.
Great.
Mouthful.
When the option to mix is selected in the protocol, the gantry lifts the tip between each mix step. Is it possible to have the Flex leave the pipette submerged for each mix instead of lifting out?
That's definitely a good feature call out. I do believe that we've done some work internally on this feature already, but that is definitely like a good use case to explore more so.
Yeah, I don't know Nick, if you had anything to add.
Yeah, and I know that this was intentional with lower volume pipetting to fully void the tip for each dispense. I'll have to speak to the team about exactly why this is employed and if there's a way to kind of turn off that feature. So I think you're anonymous, the question asker, but if you do drop your name, we can reach back out to you and figure out a solution for you. All right, Christopher, does the robot support a networking interface where a user can remote into the unit? Can this unit be accessed via software that can be run in Windows or Linux, for instance? Maybe I can kind of give a short answer to this, and Chris, we can speak offline as well. So we can remote into the unit if you're on the same network via SSH. Your second question, I'm not quite clear on what you're asking. Software that can be run on Windows or Linux. So this might be worth a longer conversation over email or a call. So I'm going to go ahead and allow you to reach out to our email, and we'll get back to you. Okay. A few questions regarding Flex. Is there a low volume limit working with 200 microliter pipette tips while writing protocols with a designer? Actually, let's answer that first one first. So is there a low volume limit with 200 microliter pipette tips?
There is, and I'm struggling to remember what it is. So we do recommend that if you are, for example, working in the 1 microliter range, that you do use the lower tip volume. I think 200 goes down to 5.
I think we technically support it at 1, but it is always best practice, and kind of most of our kind of relevant 1 microliter, 1 to 5 microliter results are kind of produced from the 50 microliter tip. But I believe we support it below that, but it's not our recommendation.
Yeah, that's from my experience, it's mostly based on the pipette for accuracy and the tips as well. So our P50 pipette goes down to 1 microliter, and our next volume range, our second and top volume range, goes down to 5 microliters reliably. So you should be able to get away with 5 microliters comfortably with 200 microliter pipette tips, which is, I think, the second part of that question. All right. Great. For lower volume applications, is the pipette touch bottom to ensure complete transfer?
You can definitely have it, written out in that way. We have, command sets that allow you to control the Z height, as well as Fran had mentioned before, the XY definition for where you are pipetting to. So as long as the labware is defined correctly, which it should be if it's taken from our labware library, or if you create your own custom definition of it, then yeah, a contact dispense mode is definitely something that you can enable, whether that's to the plate bottom or to the liquid in the well.
Great. Thanks, Nick. Okay. Let's see what we have here. How long would it take the P1000 pipette to aliquot 9 microliters each well of a 96 well plate?
I don't know off the top of my head. We can definitely work it out.
Yeah.
Yeah, in terms of being able to multi-dispense off of that, it should be relatively quick. I would say the fastest solution there would be a 96 head. So that plug for that, as well as once we kind of unveil the ability to do partial tip pickups with that 96 head, I think that is probably a good way to move forward on that. If the question there is, moving from tubes to plates for all of those, I would first specify that using the 1000 microliter pipette is probably not as good as using the P50 for 9 microliters, I believe they said. But that definitely take longer, as well as if you have to, switch out tips every time. So it depends if there's optimizations such as multi-dispense that we can utilize.
I would say that if you have a really clear idea of what you want to do, and it sounds like you do, then we can do a timing study for you. So if again, you wanted to contact us offline, and we could have a call with an FAS, and FAS could do a timing study based on your exact kind of protocol needs and give you an exact timing study for your sample number and your throughput and your pipette needs and so on.
Great. Yeah, we have about 5 questions left. Unfortunately, several of them are anonymous. I'm going to try to make my way through those. Okay. Is the Flex able to integrate barcode reader functions and crosstalk with the limbs regarding the readouts from a barcode reader?
So currently we do not have a barcode reader integration. That would be kind of possible to kind of reach out to a limbs or kind of store information in that. That is certainly on our roadmap as well.
Great. Can the gripper delid SPS labware remove and replace lids from standard and deep well plates?
Yeah, so the ability to take kind of what we would view as just like stacked labware and move one of them is functionality that we have. So you could move that to a different location.
Great. Okay. Can the 8-channel pipette use 1 tip?
Yes, it can. And it can also use a variety of the other kind of configurations there. So moving from 2 to 7. So variation with that.
What are the routine maintenance procedures that must be followed?
Yeah, so the routine maintenance for the Flex is actually kind of fairly simple. There really is no kind of need to service belts or like various like lubrications of gantry or anything like that. Really, ensuring the pipette tips themselves and the gripper paddles are clean, as well as that the deck is clean, with just like, basic, cleaning materials such as like IPA or ethanol, is, kind of the typical procedure that's necessary, kind of on a day-to-day or week-to-week maintenance schedule.
But we do recommend an annual PM you can get as part of a service contract, and that involves kind of swapping out, some pipettes and other features as well. But that's like part of a service contract, but not kind of routine maintenance that you necessarily need to do yourself on a day-to-day or week-to-week basis.
Great. Can you please share more about the HEPA UV module? What applications is this most useful for?
Yeah, absolutely. So the HEPA UV up here, so it's obviously got two components. One is a UV light source, which does go on for 15-minute increments, and is designed to sterilize the interior and the deck of the instrument. So that's particularly useful, in the genomic space, between PCR cycles, just ensuring that you're not going to carry over or cause any kind of contamination. And then the HEPA element is that there are various filters which will kind of blow air in at kind of a low volume, or kind of a low kind of throughput, and create kind of a positive pressure within the system, which is then kind of going to like basically just ensure that there are no contaminants that are coming up and in. It is 0.3 microns, so we do want to specify that it's not going to be safe for viral work, as well as it's not kind of a laminar flow hood. So it is not going to be kind of, taking anything up out of there, but it's really going to be ensuring that the samples that you have kind of within the space are going to be kept as clean as possible. And so it's good for things such as like, bacterial and cell culture work.
Great. What about the level of precision for the P50 in normalization protocols, for lower volumes than 1 microliter, i.e. nucleic acid extraction, sample normalization, sample preps? Thank you. Also, we have about 30 seconds left. Sorry to rush.
So for the P50, we do not support volumes below 1 microliter right now.
All right, that's a quick answer. Maybe one more quick one. Is the HEPA UV module strong enough to do mammalian cell culture?
It certainly is. We definitely have a number of customers who are doing exactly that.
Great. And I think that's all we have time for right now. We have a couple questions left in the queue that we'll get to after. Any closing words?
No, it's great questions from everyone. Appreciate the engagement, and thanks, Nick, for reading them out.
Absolutely. That might be a record for questions. So great job, guys.
Thanks all.
Thanks, everyone.
Thanks.
Bye.